Huawei and SMIC prepare quadruple semiconductor patterning for 5 nanometers production. According to Bloomberg's latest investigation, Huawei and Semiconductor Manufacturing International Corporation, SMIC, have submitted patents on the self-aligned quadruple patterning, SACP, pattern etching technique to enable SMIC to achieve 5 nanometers semiconductor production. The two Chinese giants have been working with the deep ultraviolet, UV, machinery to develop a pattern etching technique allowing SMIC to produce a node compliant with the US exporting rules while maintaining the density improvements from the previously announced 7 nanometers node. In the 7 nanometers process, SMIC most likely used self-aligned dual patterning, SADP, with UV tools, but for the increased density of the 5 nanometers node, a doubling to SACP is required. In semiconductor manufacturing, lithography tools take multiple turns to etch the design of the silicon wafer. Especially with smaller nodes getting ever-increasing density requirements, it is becoming challenging to etch sub-10 nanometers designs using UV tools. That is where extreme ultraviolet, UV, tools from ASML come into play. With UV, the wavelengths of the lithography printers are 14 times smaller than UV, at only 13.5 nanometers, compared to 193 nanometers of ARF immersion UV systems. This means that without UV, SMIC has to look into alternatives like SACP to increase the density of its nodes and, as a result, include more complications and possibly lower yields. As an example, Intel tried to use SACP in its first 10 nanometers nodes to reduce reliance on UV, which resulted in a series of delays and complications, eventually pushing Intel into UV. While Huawei and SMIC may develop a more efficient solution for SACP, the use of UV is imminent as the regular UV cannot keep up with the increasing density of semiconductor nodes. Given that ASML can't ship its UV machinery to China, Huawei is supposedly developing its own UV machines, but will likely take a few more years to show.